Heinrich Ernst Kniepkamp, a talented engineer, began working as a transmission designer at the MAN company in March 1923. Later, he joined an engineering firm in Rostock, and from 1926 until the end of World War II, he served in Department No. 6 of the Ordnance Office, responsible for the motorization of the Wehrmacht. The creation and development of the first line of new German fast tanks were carried out under Kniepkamp's leadership in 1937 and 1938, which would later cause German tank crews a great deal of trouble. This story will contain many technical details, but they will allow us to look directly into the core of the problem. While working in the Ordnance Office, Heinrich Ernst Kniepkamp developed a concept of military vehicles in which achieving the highest possible speed was the top priority. Following this idea, in the first half of the 1930s, he oversaw the design of a range of half-track tractors and armored cars. Their designs were similar to one another and based on the same principles, all subordinated to one main goal: attaining high speed. It must be said that Kniepkamp was not alone in this pursuit. Around the same time, the American inventor Walter Christie was working on his own racing tanks. His designs employed very powerful engines, while the transmissions and suspensions remained relatively simple. Unlike his transatlantic colleague, Kniepkamp focused not on specific power, but on its efficient use. Indeed, a significant portion of power is lost within the transmission and the track drive system. And if these losses are minimized, speed naturally increases. Furthermore, power must be used rationally, meaning that the driving wheels must receive torque close to the optimal value. This demanded the advancement of transmissions, especially gearboxes. In his line of half-track vehicles, Kniepkamp implemented several key design principles. The choice of a half-track configuration itself deserves separate attention. It is usually written that this layout was used as a relatively inexpensive way to significantly improve the off-road capability of standard trucks. However, in this case, it was about creating purpose-built, rather expensive military vehicles. The author believes Kniepkamp chose the half-track design because it allowed for automobile-style steering, that is, using a front axle. This improved handling at high speeds without the need for a more complex dual-flow steering mechanism. Kniepkamp's half-tracks became true masterpieces of technical perfectionism. Structurally, they were very expensive and complicated to produce, and eliminating their numerous teething problems took many years. However, at that time, the Germans had the luxury of time, and Kniepkamp's approach justified itself. He gave the military exactly what they wanted: tractors with high speed on European roads and good off-road mobility. After the war, the Americans conducted an interesting experiment. They installed the running gear of a German half-track tractor onto a light tank M24 chassis and compared it to the original suspension. The results were revealing. The effort required to tow the tank without tracks using the German running gear was 20% lower, and with tracks, the difference increased to 37%. With its native suspension, the M24 coasted 1.3 to 2 times shorter distances than with the German system. A significant role was played by the design of the tracks with rubber pads. On hard surfaces, they provided excellent grip and did not damage the road, while in mud they acted as effective cleats. Kniepkamp's success in designing tractors and armored vehicles greatly increased his influence and authority. At the end of 1936, he was appointed civilian head of Department No. 6 of the Ordnance Office, and from that moment on, relying on his extensive experience, he began developing a new line of high-speed tanks. In December 1936, Department No. 6 began developing a new line of tanks. Kniepkamp set the task of radically improving the mobility of combat vehicles. To achieve this, he proposed designing new running gears based on ideas already tested on half-track vehicles. These included individual torsion bar suspensions, large-diameter road wheels, combined rubber-metal tracks, semi-automatic gearboxes, and more powerful engines. Another crucial issue arose: the turning mechanism. Unlike half-tracked vehicles, tanks could only turn using a special steering mechanism. Existing designs did not provide good handling at high speeds, which meant that the concept of a fast tank turned into an empty promise. In 1937, Kniepkamp, according to his own words, invented a new twin-flow multi-radius steering mechanism. It was based on the differential turning systems used in the French Char B1 and Somua S-35 tanks, but featured a completely different structural design. The system worked as follows. The turning mechanism had 2 input shafts, One was connected to the gearbox and the other directly to the engine. When moving forward, power was transmitted to the drive wheels only through the gearbox. To initiate a turn, a second power flow from the engine was engaged, and through an idler gear, it accelerated one track while slowing down the other. In neutral gear, power was transmitted solely through the second flow, allowing the tank to turn on the spot. It is easy to understand that in this system, the turning radius depended on the ratio of the two shafts' rotation speeds, that is, on which gear was engaged. Thus, the higher the tank speed, the larger the turning radius. This greatly improved handling because attempting to make a tight turn at high speed could otherwise result in a tank drift straight into a ditch. In the twin-flow turning mechanism of the Somua S35, the number of calculated turning radii matched the number of gearbox speeds, which was a significant achievement at the time. However, Kniepkamp found this insufficient. He proposed adding a 3-speed gearbox to the turning mechanism itself. Depending on which gear was engaged in this secondary gearbox, the difference in track speeds varied. One track accelerated and the other decelerated faster or slower. As a result, at each driving gear, the tank could turn with not just one, but 3 different calculated radii. In other words, Kniepkamp had invented a transmission system with 2 gearboxes. One controlled the driving speed and the other defined the turning radius. A special mention should be made of the excellent control system. Shaftless gearboxes were equipped with a semi-automatic shifting system. The driver set a small lever to the desired gear position and then pressed a pedal. The semi-automatic mechanism performed all synchronization and clutch operations independently and even adjusted fuel supply during the process. The steering mechanism was operated with a wheel. Depending on its tilt angle, the tank turned with a specific radius. These control elements required no significant physical effort from the driver and were exemplary in terms of convenience. It is worth noting that gearboxes without shafts did not become popular because of the complexity of the semi-automatic control system. In such gearboxes, as the name suggests, there are no shafts that connect the gears. Gears are formed by engaging pairs of gears in different combinations. Thanks to this, each pair of gears increases the number of speeds not by 1, but immediately by 2. Hence the maximum number of speeds for forward and reverse movement with an excellent range at minimal size and weight. For example, in the gearbox of Panzer III, models E, F, and G 6 pairs of gears produced 16 transmissions for forward movement and 8 for reverse. But in practice, only 10 forward gears and 4 reverse gears were used. The problem is that controlling such a gearbox would require 5 levers, and the driver has only 2 hands. Therefore, gear selection was handled by a semi-automatic mechanism. Another problem is connected with synchronization of speeds. When shifting gears, it was necessary to brake and accelerate not a single pair of gears, which an ordinary cone synchronizer could handle, but all pairs at once. Because of this, it was necessary to add a central synchronizer that consisted of a brake and an accelerator. The shifting process looked like this. The first pair of clutches began to shift, and depending on the gear, the brake or the accelerator was engaged simultaneously. After its shifting, the synchronizer was switched off. The next pair of clutches began to shift with simultaneous engagement of the brake or the accelerator, and so on until the gear was fully engaged. All these individual operations had to be carried out in a strict sequence in a matter of mere milliseconds. And we have not even touched on controlling the main clutch and the throttle. According to Heinrich Ernst Kniepkamp, designing and debugging such a mechanism could stretch over 3 to 4 years. To continue the discussion, a small digression is required concerning the particularities of armored vehicle development in Germany in those years. Of the many companies, only a few giants, for example the Krupp and Daimler-Benz concerns, could afford to develop a tank almost entirely on their own. Therefore, the process of creating armored vehicles usually looked like this. The Armaments Directorate formulated requirements for the future tank and sent different companies tasks for its various parts. For example, Zahnradfabrik developed the gearbox, Maybach the engine, Daimler-Benz the running gear with the hull, and Krupp received the turret. It got to the point that for the Panzer I Model A, the lower part of the hull was designed by Krupp and the upper part by Daimler-Benz. By Kniepkamp's time, the tank development process had become much stricter and more centralized. Now the Armaments Directorate sent companies tasks with detailed instructions about which engines, transmissions, and running gear had to be used. In fact, the concept of the tank was created in Department No. 6 under Kniepkamp's leadership, and companies served only as implementers of the conceived design. That is why many German tanks, even when developed by different companies, look so similar to each other. This system had its weak point. If the approach of Department No. 6 proved unsuccessful, problems arose at once in several tanks. Moreover, competition between different concepts in armored vehicle development practically disappeared. If a company did not agree with Kniepkamp's ideas, he simply passed the order to competitors. Thus, the Armaments Directorate actively lobbied the interests of some companies and sank the developments of others. Having started work on a new line of tanks, Kniepkamp, without being aware of it himself, planted a time bomb under the tank forces. But let us not get ahead of ourselves. Kniepkamp was completely dissatisfied with the state of German tanks by the end of 1936. Outdated running gears with small road wheels and leaf spring suspensions were unsuitable for high speeds. On the second and third models, they had to be redesigned several times, but without much success. There was another issue as well. During the development of entirely different concepts for a light and a new heavy tank, the Germans ended up with two very similar vehicles, the medium tanks of the third and fourth models. There was no reason to produce both simultaneously. Finally, the Spanish Civil War demonstrated that the era of protection against only bullets was over. Tanks now needed armor capable of withstanding shells. Based on these considerations, the 6th Department planned a new line of tanks. The concepts of the light tanks of the first and second models generally satisfied the Germans, but the outdated chassis had to be replaced by completely new designs. Of the two medium tanks, the third and the fourth models, only one would remain in production, but in two variants, with 1.5-inch and 3-inch guns. Finally, a heavy tank with shell-resistant armor was added to the tank lineup. Armed with advanced developments, in February 1937, Kniepkamp approached the Krupp Company with a request for a new light tank that would incorporate his ideas to increase maximum speed. Compared to the light tank of the first model version B, it was expected to double its speed, from 25 to 50 miles per hour. The lead Krupp engineer, Erich Wolfert, disagreed with the 6th Department's ideas and refused to sign the contract, preferring to work in the old way. Then Kniepkamp declared that if Krupp did not agree by May 15th, the task would be given to another company. The industrial giant flatly refused, perhaps hoping to settle the issue through its connections. But to no avail. The work on the light tank of the first model with the new design was transferred to the Krauss-Maffei Company, which had previously designed a half-track tractor under Kniepkamp's orders. Thus began the story of the light tank of the first model version C. The chassis for the light tank of the second model was developed by MAN, so on January 27, 1937, Kniepkamp turned to that company. The task called for the creation of an entirely new high-speed chassis for the second model version D, in which even the overall layout was changed compared to the early 2s. Unlike Krupp, MAN decided to cooperate with the Armaments Office, and as a result, it continued to receive orders. As for the medium tanks, their situation became clear rather quickly. Krupp engineers rejected Kniepkamp's ideas and categorically refused to use torsion bar suspensions, citing the failure of a previous project. Daimler-Benz, however, agreed to develop a new chassis with a torsion bar suspension, which was expected to double the maximum speed, from 22 to 43 miles per hour. This determined the Armaments Office's position. The new medium tank of the third model version E was to become the only medium tank. The fourth model by Krupp was removed from production as redundant since its turret with the 3-inch gun could be installed on the new third model tank. As for the heavy tanks, the Henschel Company was tasked with developing their chassis. Like MAN, it did not argue. It simply followed orders without insisting on its own vision. At that time, the Germans lacked sufficiently powerful and compact tank engines in the 600 to 700 horsepower range, so the 6th Department decided to limit the heavy tank's weight to only 30 tons, 66,000 pounds, and use the same engine and transmission as the new medium tank. Within this limit, they managed to fit a short 3-inch gun from the fourth model in circular armor 2 inches thick. It could protect against 1.5-inch guns in real combat conditions and was therefore considered the minimum shell-resistant standard. The heavy tank went through many designations, but is best known under the codes DW and VK 30.01H. The plans looked very optimistic. The mobility of the tanks was set to increase dramatically. The issue of unifying medium tanks was being resolved, and in addition, a heavy one was being developed. Let's see how well these plans were implemented. In 1937, the Daimler-Benz company prepared a design for a medium tank. The number 38 in its name indicated the year when mass production was expected to begin. Despite the familiar designation, it was, in fact, an entirely new tank. The first production model differed from the previous version with a completely redesigned hull, both in shape and dimensions. It was fitted with a new, more powerful Maybach engine, a fundamentally different transmission with a complex 10-speed Maybach Varirex gearbox, and an intricate steering mechanism with 3 turning radii. The tank also received a new running gear featuring rubber metal tracks, torsion bar suspension, and 6 road wheels on each side. Thanks to these changes, its maximum speed doubled, from 22 to 43 miles per hour. The complex steering mechanism combined with the 10-speed gearbox provided 30 possible turning radii. Is that a lot or a little? For comparison, the Soviet T-34 had only 1 calculated turning radius, while the T-62 had just 2. At the beginning of 1938, the first prototype went on trials. The consequences of developing such a complex design in a short period quickly made themselves known. The chassis literally fell apart. The rubber pads of the tracks wore out too quickly, and the rubber rims of the road wheels delaminated at speeds above 25 miles per hour. The intricate steering mechanism could not be made to work properly, and numerous problems arose with the reliability of the gearbox control system. The work was delayed even though preparations for serial production were already supposed to begin according to the plan. The design had to be ruthlessly simplified. A simple 1-radius steering mechanism was installed, and the rubber metal tracks were replaced with conventional ones. But even the simplified version of the tank made its first steps with great difficulty. Throughout 1938, only 1 tank was accepted for service. From January to April of 1939, only 6 tanks were delivered instead of the planned 24. The main reason was the inconvenient gearbox. Its design had to be reworked, which slowed down production. Soon, complaints began to pour in from military units about its reliability. There were cases where pneumatic cylinders failed, causing some gears to stop working, while the neutral gear sometimes engaged on its own. The running gear also suffered. Torsion bars broke, and the rubber rims of the road wheels delaminated at high speeds. This raised a logical question. If the running gear could not withstand speeds above 25 miles per hour, why did the tank need such a complex and troublesome gearbox? And now let us recall that the heavy tank was unified with this medium tank in terms of transmission. It goes without saying that the very first trials revealed an entire list of problems. The chief tank designer at Henschel, Erwin Aders, noted that the complex steering mechanism worked properly only on good roads, while off-road it functioned more or less adequately only at 1 radius. Many problems arose with the electrical control system. Initially, the steering mechanism was operated not by pneumatics or hydraulics, but by electromagnetic clutches. Later, these had to be abandoned, and the mechanism had to be redesigned from scratch. In addition, replacing the rubber metal tracks with traditional ones required a complete redesign of the running gear on the new heavy tank. As a result, when the war began, Germany faced it without any heavy tanks at all. Things were going slightly better with light tanks, meaning bad but not disastrous. After the tests, the Germans had to abandon the rubber metal tracks and the complicated turning mechanism on one of the light tank models. Only the semi-automatic gearbox worked properly, and even that was because it had already been perfected on half-track tractors. The new model of the light tank went into production in a reduced form. It had no decisive advantages over the previous version, and soon gave up its place on the production line to the very tank it was supposed to replace. As for the new design of an even lighter tank, its new chassis never entered mass production at all. Seeing that the set requirements could not be met, engineer Kniepkamp waved his hand at these developments back in 1938 and began work on new light tanks. They took a very long time to refine, and by the time production became possible, their armament was strikingly weak. The beginning of the war sobered up the German leadership, and for good reason. The production plan for the main medium tank had been disrupted, and there were no heavy tanks in the army at all. Things were slightly better with light tanks, since one of the models with a new suspension on leaf springs turned out to be a good vehicle and managed to compensate for the failure of other designs. Because the new medium tanks arrived in small numbers and broke down regularly, the Krupp company managed to defend the production of its own medium tank. Erich Wilfert turned out to be right. The half-track tractor design could not be adapted for tanks. The leadership of the Third Reich began the process of reviving competition and giving companies greater freedom in creating tanks. On the initiative of Adolf Hitler and Reich Minister Fritz Tod, a tank commission was established. It dealt not only with the creation of new tanks, but also with the evaluation of projects, meaning it effectively became a competitor to the 6th Department of the Armaments Office. On the 3rd of September 1939, Ferdinand Porsche became the head of the commission, and by December, the Porsche company had already begun work on a heavy tank. In October 1939, Daimler-Benz received permission to design a new medium tank independently from the 6th Department according to its own vision. Finally, on the 31st of July 1940, the Czech companies Skoda and BMM were involved in the development of new light tanks. Thus, the Germans ensured themselves in all three directions. Hitler cursed the Armaments Office for its sluggishness and incompetence. Not only had it allowed a series of mistakes, but it also corrected them far too slowly. Although the small number of tanks of new types is usually explained by the unpreparedness of German industry, much of the blame lay with the 6th Department of the Armaments Office and its inadequate approach to design. To solve such problems, in 1940, Fritz Todt was appointed Reich Minister of Armaments and Munitions. The head of the Armaments Office, General Karl Emil Becker, tried to resist Todt's growing influence, but a representative of Krupp discreetly hinted that compromising information about Becker's family existed. Crushed by Hitler's criticism, Becker shot himself the same day. After the war, these crucial processes were not properly understood, and many explanations emerged based on the assumption that the Germans had developed tanks more or less rationally. Too few tanks of new types at the start of the war? Then the factories must have simply worked in peacetime mode and failed to increase output. No heavy tanks in the army? They were unnecessary for a blitzkrieg. That was the plan all along. Two similar medium tanks produced in parallel? Well, one of them must have actually been a heavy tank, so there was no real problem. In short, whatever happened, it supposedly only made things better for the Germans. It remains unclear, however, how they managed to lose the war in the end. As for Kniepkamp, he was neither dismissed from his post, nor sent to forced labor, nor executed. Despite a series of costly failures, he continued to hold one of the key positions within the 6th Department and did not lose his authority. However, until the very end of the war, he had to face opposition from those who refused to support his concept of tracked chassis. After the war, Kniepkamp was asked why he had insisted on achieving such high speeds for tanks. He replied that he did not know what tactical sense it could have had, especially since tanks were transported by rail over long distances. Nevertheless, the speed of 40 miles per hour was achieved, though one could only add at what cost.